Yes, hello everyone. So today we have our next topic, that is structure of alkanes. Okay. So in structure of alkane, you know, carbon that form how many bonds in alkane? Carbon forms four sigma bonds. Let us say methane. So in methane, you know, carbon forms four bonds with hydrogen, four sigma bonds. Okay. As four sigma bonds are formed, so what is the hybridization of carbon? It is sp3. And what is shape? Shape is tetrahedral. Okay, right? Sp3 hybridization and tetrahedral shape. So alkanes, all alkanes have tetrahedral structures, right? In 3D, and what is the angle? Almost 109 degree, 28 minutes. Okay. Good evening, Anu. So, आसाद, ये जो आपका क्लास आज देखते हैं यार, आज मैं थोड़ा लेट हो गया था. Okay, in 3D, it is like this. In this case, normal bonds, these normal bonds, they are considered as on the plane of the paper. And this wedge represents bond towards the observer. And this dashed, this is called wedge. Okay, and this is dashed line. So dashed bond, that is away from the observer. Okay, so in this way, this is 3D structure of alkane. This is three-dimensional right? Now in 2D, or we can say um, or another 3D view. Another 3D view is like this. This is another 3D view. And last one, this one. This is two-dimensional structure, 2D structure, or we can say Fisher projection formula. Okay. Done? But I have just drawn the structures of alkane. See, in alkanes, carbon form 4 sigma bonds. So as carbon form 4 sigma bond, it is sp3 hybridized and it is tetrahedral arrangement. Shape is tetrahedral. Okay, it has tetrahedral structure and angle is almost 109 degree, 28 minutes. Or this is 3D arrangement. The normal bonds that is the bonds on the plane of the paper. Normal bonds, these are the bonds on the normal lines, sorry, that's the bonds on the plane of the paper. Okay, and this one is towards the observer, that is wedge, and this dashed means away from the observer. Another 3D view is like this, and this one is Fisher projection formula. Okay, that is called 2D structure or Fisher projection formula. That's it. Now, after the structure, let us discuss the methods of preparation. So, in method of preparation, you know, these are saturated hydrocarbons. Alkanes are saturated hydrocarbons. So, they can be prepared from unsaturated hydrocarbons. So, first is from unsaturated hydrocarbons. So, you know, unsaturated hydrocarbons are alkenes and alkyne, ethene, propene, or even propine, or even ethine. These are ethene, propene, propine. So ethene, propene, propine, when they are treated with hydrogen, you know, in a alkyne we need 2 moles. In the this is called catalytic hydrogenation. Means this is a process of addition of hydrogen, okay, to this unsaturated compound in the presence of a catalyst, and catalysts are nickel or platinum or palladium. In all the cases, these are the catalysts used. So hydrogen is added, the pi bond is replaced by sigma bonds. In second case, again 2 hydrogens are added, 2 hydrogen atoms, and pi bond is vanished, and we get the sigma bonds instead of pi bonds. In this case, 2 moles of hydrogen molecule are added, and we get propane. And this is one type of addition reaction. और इसको क्या बोलते हैं बेटा, क्योंकि हाइड्रोजन इज एडेड. ओके, so this is called hydrogenation. Process of addition of hydrogen is called hydrogenation. And you know, hydrogen addition means reduction. Okay, so this is also called reduction, and this reduction is taking place in the presence of catalyst. So it is also called catalytic hydrogenation or catalytic reduction. Done? Catalytic hydrogenation or catalytic reduction. Do you know what is nickel? अब nickel यूज करने का क्या सेंस है? अगर निकल यूज करते ऑर्डिनरी तो क्या होता? अगर निकल होता क्या एक्चुअल में? निकल क्या है? इट इज एक्टिव फॉर्म ऑफ निकल. निकल क्या है? एक एक्टिव फॉर्म है ऑफ निकल. तो कैसे बनती है ये एक्टिव फॉर्म? ओह आलम, यू नो व्हाट इज दिस? टेल मी. तो इसमें क्या करते हैं, कैसे बनता है ये कि निकल एल्यूमिनियम का एलॉय लेते हैं, ठीक है ना, और उसको NaOH में डिसॉल्व कर देते हैं, ठीक है, तो क्या होगा, यू नो एल्यूमिनियम तो इसमें डिसॉल्व हो जाएगा सोडियम हाइड्रोक्साइड में, एल्यूमिनियम इज डिसॉल्व्ड एंड वी गेट फाइनली डिवाइडेड निकल, मतलब वी गेट निकल इन फाइनली डिवाइडेड स्टेट, इसलिए इसको बोलते हैं एक्टिव निकल, ठीक है ना, रेनी निकल। अगर ऑर्डिनरी निकल लेते हैं हम, थोड़ा टेम्परेचर हमें हाई लेना पड़ेगा, निकल से भी हो तो जाएगा, है ना, हाइड्रोजनेशन जो है इसकी ऑर्डिनरी निकल से भी हो जाएगी, बट जो टेम्परेचर चाहिए दैट इज समवट हायर, ठीक है ना, उनमें ऑर्डिनरी टेम्परेचर प्रेशर पे हो जाएगा अगर रेनी निकल यूज करते हैं। अगर सिर्फ निकल यूज करूं मैं तो डिफरेंस क्या आता है देख लो, देखो ये था हाइड्रोजन था, रेने निकल लिखा था मैंने, है ना, या प्लेटिनम या प्लेडियम, तो मैंने कोई टेम्परेचर या प्रेशर मेंशन नहीं किया था, क्यों, क्योंकि नॉर्मल टेम्परेचर प्रेशर पे वो रिएक्शन हो जाता है। बट अगर मैं सिर्फ निकल लिखता हूँ दैट इज ऑर्डिनरी निकल, तो मुझे जो टेम्परेचर चाहिए दैट इज वेरी हाई, 523 टू 573 केल्विन टेम्परेचर चाहिए तो रिएक्शन हो पाएगा, ये याद रखना, बस ये डिफरेंस है। हाँ राला, वेरी गुड, स्पॉन्जी निकल, स्पॉन्जी मतलब कि निकल के, देखो निकल वैसे ऐसा होना चाहिए ना कि उसके सारे तरफ निकल निकल निकल, है ना, ऐसे होना चाहिए, तो जब ये बॉन्ड टूटे हो सारे तो एक्टिव साइड्स बढ़ जाएंगी ना, बहुत बढ़िया बेटा, ठीक है, ओके वेरी गुड। और इस रिएक्शन को क्या बोलते हैं, ऑर्डिनरी निकल से जो रिएक्शन करते हैं हम, इसका ऑर्डिनरी निकल से ये करे रिएक्शन, है ना, तो इस रिएक्शन को पर्टिकुलरली नाम देते हैं हम सेबेटियर एंड सेंड्रन्स रिएक्शन, स्पेशल नाम इसका है, ठीक है, ओनली विद ऑर्डिनरी निकल, ठीक है, डन। तो ये हो गया अपना फर्स्ट प्रिपरेशन फ्रॉम अनसैचुरेटेड हाइड्रोकार्बन, ठीक है। अब आ जाओ जो बहुत ही इंपॉर्टेंट है 11th स्टैंडर्ड के लिए, दैट इज, याद है ये रिएक्शन सबने किया ही होगा, उस रिएक्शन बहुत ही इंपॉर्टेंट है, इट इज एक्सपेक्टेड क्वेश्चन, एग्जाम में आ सकता है, ठीक है, ये याद रखना, इंपॉर्टेंट है फ्रॉम द एग्जामिनेशन पॉइंट ऑफ व्यू। तो वुड्स रिएक्शन में क्या होता है कि हम क्या लेते हैं, एल्काइल हैलाइड, ठीक है, प्रेफरेबली ब्रोमाइड और आयोडाइड लेते हैं, है ना, बट क्लोराइड से भी हो जाता है, बट ब्रोमाइड और आयोडाइड्स आर प्रेफर्ड वन, ठीक है। नाउ इट इज ट्रीटेड विद मेटेलिक सोडियम, तो किससे करते हैं, मेटेलिक सोडियम से, अल्काइल हैलाइड को मेटेलिक सोडियम से करते हैं इन द प्रेजेंस ऑफ ड्राई ईथर, इन द प्रेजेंस ऑफ ड्राई ईथर, ठीक है, और ड्राई ईथर से करने के बाद वी गेट अ सिमेट्रिकल ईथर, okay, containing डबल नंबर ऑफ कार्बन एटम्स, कितने हो जाते हैं, कार्बन डबल, जितने अल्काइल ग्रुप में होते हैं उसके डबल हो जाते हैं, और इस रिएक्शन को बोलते हैं वुड्स रिएक्शन। क्या करते हैं, अल्काइल हैलाइड is treated with metallic sodium in the presence of dry diethyl ether, or simply you can write dry ether, so a symmetrical alkane is formed, Symmetrical alkane means alkane with even number of carbon atoms. Symmetrical alkane is formed, that is the alkane with even number of carbon atoms. ठीक है, means कार्बन एटम्स इतने प्रेजेंट होते हैं है ना, उसके डबल नंबर. दिस इज कॉल्ड वुड्स रिएक्शन. फॉर एग्जांपल हम सिंपल एग्जांपल लेते हैं कि हमारे पास है मान लिया मिथाइल ब्रोमाइड. ओके, अब ये जो मिथाइल ब्रोमाइड है इसको मैंने सोडियम से किया, तो 2 मिथाइल ब्रोमाइड के मोल्स यूज होंगे. रिमूव हो जाएगा इन द प्रेजेंस ऑफ ड्राई ईथर. ठीक है, तो वी गेट इथेन along with सोडियम ब्रोमाइड. तो इवन नंबर के लिए तो ये बेस्ट मेथड है. ठीक है, अगर सिमेट्रिकल एल्केन बनानी है ना, इवन नंबर ऑफ कार्बन एटम वाली. सिमेट्रिकल एल्केन का मतलब है इवन नंबर ऑफ कार्बन्स वाली एल्केन. सिमेट्रिकल एल्केन मींस एल्केन with even number of carbon atoms. ठीक है, अगर तो ऐसी एल्केन बनानी है तो दिस इज द वन ऑफ द बेस्ट मेथड. बट अगर हमें ट्राई करना है कि ऑड नंबर वाली बने, कैसी एल्केन बनानी है विद ऑड नंबर ऑफ कार्बन एटम, देन इट इज फेल्ड. तो क्या होता है, वी गेट मिक्सचर ऑफ एल्केन्स, और मिक्सचर ऑफ एल्केन बनता है और उनका जो बॉइलिंग पॉइंट होता है दैट इज वेरी क्लोज टू ईच अदर, एंड दैट्स व्हाई दे आर वेरी डिफिकल्ट टू सेपरेट, और वी कैन से दे कैन नॉट बी सेपरेटेड बाय सिंपल डिस्टिलेशन, और इवन फ्रैक्शनल डिस्टिलेशन से भी सेपरेट नहीं होते हैं. दैट्स व्हाई ये एक ड्रॉबैक है वुड्स रिएक्शन की. इट इज यूज्ड फॉर द सिंथेसिस ऑफ ओनली सिमेट्रिकल एल्केन्स एंड नॉट फॉर द प्रिपरेशन ऑफ अनसिमेट्रिकल एल्केन्स. Unsymmetrical alkane means alkane with odd number of carbon atom. For example, if we attempt to prepare an alkane with 3 carbons, तो 1 कार्बन वाला चाहिए और 2 कार्बन वाला चाहिए. सही है, in the presence of right. ठीक है, तो वी गेट प्रोपेन along with सोडियम आयोडाइड. हेलो, तो हमने क्या सोचा कि एक मिथाइल आयोडाइड था, एक इथाइल आयोडाइड था, और हमने प्रोपेन तो मिल गया, हमें हमारा काम हो गया, हमें प्रोपेन चाहिए था. गुड इवनिंग बेटा. बट कीप इन माइंड व्हेन वी हैव alkanes, different alkyl halides, what happened? So it is a mixture of those all the alkyl halides. So methyl iodide can react with another methyl iodide. So there are millions of molecules. So we get ethane as the product, and ethyl iodide. Yes beta, this is most basic chapter for NEET as well. इसलिए मैंने इनको बोल दिया है सबको कि भैया ये वाला चैप्टर तो आपको करना ही है, सिर्फ नॉलेज के लिए, पास होने के लिए नहीं. तो we get these many products, 3 alkanes. Rather than getting single product, 1 alkane, we get 3 products. That is propane, ethane, butane. We are attempting to prepare propane, but along with that we get ethane and butane as well, and their boiling points are so close that they cannot be separated even by fractional distillation. Okay, this is the reason that it is method convenient to prepare symmetrical alkane. Okay, this method is used for the synthesis of only symmetrical alkanes. Why only for symmetrical beta? Because unsymmetrical alkane can be formed, but it is with side products. Along with unsymmetrical alkane, we get other two alkanes as well. Means we get mixture. We are not getting pure alkane, and that mixture is such that those alkanes have very close boiling point, so they cannot be separated. So this is not the best method to prepare unsymmetrical alkane. This is the reason. What did Alam? No, what is the there is no need of mechanism actually, but can be free radical or can be um, organometallic compound can be formed like okay. Now next is reduction of alkyl halides. That is also in the book. Reduction of alkyl halides. So alkanes can also be reduced by the can also be prepared by the reduction of alkyl halides. Again, preferably bromides and iodides because they are easily that can be easily broken. Okay, so there are different reagents like alkyl halide. When it is treated with zinc and HCl, we get alkane with same number of carbons along with hydrogen halide. Okay, beta. So we can prepare them like this. Actually, what would happen? This is let us take example like we have methyl chloride. So zinc along with H plus. Medium is acidic. So we get methane is one of the hydrogen is attached along with Zn2 plus and zinc is into zinc 2 plus. Okay, and Cl as a negative one. So this is the product form. Okay, same zinc can be used with acetic acid even, or zinc can be used with NaOH. Means there are different agents. Zinc HCl, zinc with acetic acid, zinc and NaOH, or zinc copper couple, okay, and alcohol. So these are the reagents used to convert alkyl halide into alkane with same number of carbons. Say alkyl halide to form alkane with double number of carbons, we use Wurtz reaction. Alkyl halide to form alkane with same number of carbons, we use these reagents. Okay. Now next is decarboxylation. What is decarboxylation? Yes. Do you know? What do you mean by decarboxylation? So this is actually the process of removal of CO2 from an organic compound. OC means organic compound. Okay, that is called decarboxylation. For example, we have carboxylic acid. We treat it with soda lime. What is soda lime? It is sodium hydroxide and calcium oxide mixture in the ratio of 3:1. Removal of CO2 and soda lime. Question may be asked, what is soda lime? So keep in mind, soda lime is mixture of sodium hydroxide and calcium oxide in the ratio of 3:1. Okay, so when it is treated, we get, yes, what would we get? We get alkane with one carbon atom less than the carboxylic acid, along with sodium carbonate. Okay, temperature is high, 630 Kelvin temperature is required, but this is the method. Prepare methane. This is the method to prepare methane. See, we have acetic acid. First, it is treated with sodium hydroxide. So we get sodium acetate. Means acid-base reaction takes place with water. Then sodium acetate is treated with another molecule of sodium hydroxide in the presence of calcium oxide at 630 Kelvin. Calcium oxide is a drying agent. So there is a removal of sodium carbonate and formation of alkane. Alkane, that is methane, with one carbon atom less than the carboxylic acid. Similarly, we can prepare others. Now tell me, what happened if sodium hydroxide alone is used? Yes, tell me. See, with sodium hydroxide alone, reaction could have been completed. Okay, we can complete with sodium hydroxide alone, but calcium oxide is preferred. Its role is first to permit the reaction to carry it out at higher temperature so that complete decarboxylation takes place. And second, calcium oxide keeps sodium hydroxide dry, because sodium hydroxide is, it is hygroscopic. Someone asked me what is hygroscopic. Abhay. Yes. So sodium hydroxide is hygroscopic. What it means? Sodium hydroxide absorb moistures. It absorbs moisture. So calcium oxide that dry up the mixture. No, alkane is formed, beta. Even with sodium hydroxide, we get alkane. Okay, but difficulty is this one, that we cannot keep the temperature high. Okay, or second thing, calcium oxide keep the mixture dry, because we need fusion mixture. Okay, to fuse the mixture, it should be dry. Okay, in this way we can prepare methane. Done. Now next one. always electrolytic method. So in always electrolytic method, what we do? We have a first we take concentrated aqueous solution of the sodium or potassium salt of monocarboxylic acid. Like if we have sodium carboxylate, okay, so sodium carboxylate is electrolyzed. Sodium carboxylate is sodium salt of carboxylic acid or potassium salt of carboxylic acid is electrolyzed and alkane is formed as a product. See, water, electrolysis, we get alkane along with sodium hydroxide, H2 gas and CO2 gas. 2, 2 because R, double R is there. So 2 and 2. These are the products formed. Here N is the number of carbon atoms. Good evening, doctor. How are you? What we do here, in this case, first part is 2 moles of sodium alkylate. First ionization takes place. So after the ionization, what do we get? RCO negative and Na positive. Okay, and at the same time, 2H2O, they are also ionized. To get 2H plus and 2 OH negative ions. Now, as electrolysis takes place at anode, at anode, which ion will move towards anode? Obviously anion, because at anode electron is lost. Now at anode, RCO negative, that will lose the electron and we get write it like this. Okay, complete C double bond O and O negative. Now when 2 electrons are lost, okay, so we get 2 moles of carboxylate free radical, and this free radical is highly unstable. Free radical is highly unstable, so it immediately gives CO2 along with 2 free radicals, and those 2 free radicals will attach with each other and we get alkane along with 2 CO2. Sometimes question is that carbon dioxide, where carbon dioxide is formed? So carbon dioxide is formed in Corbe's reaction at anode, okay, along with the alkane. Now at cathode, we have H plus and Na plus. H plus and Na plus move towards cathode. Now when they move towards cathode, electrode potential of H plus is higher. E naught value of H plus is higher than that of E naught value of Na plus. Reduction potential of sodium is negative and standard reduction potential of hydrogen is 0. So that means electrode potential of H plus is higher than that of Na plus. That's why H plus ion is charged to produce hydrogen gas. 2H plus ion will gain those 2 electrons which are lost at anode and we get H2. First we get hydrogen atoms, 2 hydrogen atoms, but hydrogen atoms are highly unstable. That is called primary change, and therefore we get H2 gas. H2 gas is formed at cathode. Always reaction जो है that laid the foundation for the development of organoelectrochemistry. This is whole electrochemistry. Yes, but at cathode, at anode oxidation will take place and at cathode reduction takes place. Good. Two alkyl radicals. So two alkyl radicals, those two alkyl radicals join means form bond immediately because they are highly unstable. Now, what are the limitation of this rule? Again, see, limitation is again the same. We get alkane with even number of carbon atoms only, but not alkane with odd number of carbon atoms. Limitation of Kolbe's reaction is same. It can lead to the formation of symmetrical alkane, or we can say alkane with even number of carbon atoms. We cannot prepare alkane with odd number of carbon atoms by using this method. Okay. Now, next is by the action of water on beryllium carbide. Carbide means compounds of carbon with the metal. This is called beryllium carbide or Al4C3, that is aluminium carbide. So action of water on this, obviously beryllium 2 plus. So beryllium 2 plus will get those OH negative ions to give BeOH twice, along with, yes, we cannot prepare odd alkane with odd number of carbon, and methane. Here we get aluminium hydroxide along with methane. Okay, so 2 BeOH twice, 4 AlOH twice, 3 methane, 1, so it is 4, and here 4th is a 12H2. Okay, so in this way we get methane in both the cases. This is aluminium carbide, and this is beryllium carbide. Done. So these are the methods of preparation. Even Kolbe's electrolytic method is also there, but that is not covered in the our syllabus. So that's why we are not taking that. I will make a video separately for that. Okay, you can watch afterwards after your exams. Okay, now let us see the physical properties of okay, let us stop here today. Okay, these are the total methods of preparation. These are methods of preparation, but in these methods of preparation, most important is, which one is most important? Yes, tell me. Most important is Wurtz reaction and always electrolytic method. These two are very, very important. From the examination point of view. Okay, Siddharth is there, Mansi, Ralam. Yes, Wurtz reaction and Kolbe's electrolytic method. Okay, thank you all. See you tomorrow at the same time.